Where can we find planets that might be suitable for life as we know it? One way astronomers search for potentially habitable worlds is by studying the characteristics of a star system and then identifying the zone around that star where conditions might be right for life. It's called the habitable zone, also known as the Goldilocks zone. Here's why. You know how Goldilocks and the Three Bears is a classic children's story about a girl who sneaks into the house of a family of bears and tests various household items, like their chairs, their beds, and their tables. And for each item she tests, Goldilocks chooses a middle option. She doesn't want anything too soft or too hard, too hot or too cold, too big or too small. And it's the same for planets in a solar system. Scientists are looking for a middle option, not too extreme and not too boring. And they do this by looking at a few key characteristics. First, scientists want to know what kind of star the planet is orbiting, because a star's size determines the amount of light and heat it gives off. And that in turn affects the size of the habitable zone. For example, our sun is medium-sized, so its habitable zone is medium width. But a star with twice the mass of our sun would have a wider habitable zone because that star gives off more light and heat. And a smaller star would have a narrower habitable zone. Next, scientists consider the planet's distance from its star. Planets closer to their stars receive more light and heat and are more likely to have liquid water on their surface. But if a planet is too close to its star, it will be tidally locked, meaning one side of the planet always faces the star and the other side is in permanent darkness. And if a planet is too far away from its star, it could have a thick ice layer on its surface because there is not enough heat to melt it. So just like Goldilocks, scientists are looking for a planet that's not too hot and not too cold, but just right for liquid water to exist. Finally, scientists look at how much light and heat the planet receives from its star. If a planet receives too much light and heat, like Venus does, it could have a runaway greenhouse effect, where the atmosphere traps heat and the surface temperature gets too hot for life as we know it. If a planet receives too little light and heat, like Mars does, it could have a weak greenhouse effect and the surface temperature could be too cold for life. Again, scientists are looking for that Goldilocks middle option, not too hot and not too cold, just right. If a planet is found that has all these characteristics, it might be considered habitable. But keep in mind, just because a planet is in the habitable zone of its star does not mean that it actually has life. It just means that the conditions might be suitable for life as we know it. Researchers use computer models to simulate different scenarios to better understand the conditions for life elsewhere in the universe. And you can use a model to better understand the math behind these scenarios.